this is silicon. Today I'm going to be looking at alkanes, the properties and bonding. So what is an alkane? So an alkane, this is a group of saturated hydrocarbons. So this is organic chemistry, ladies and gentlemen, and we have different types of organic compounds. We have alkanes, also we have alkenes, we have alcohols, we have carboxylic acids, also we have esters. Yes. So these are different types of organic compounds, their families, their homologous series. But today I'm going to focus on alkanes, which is one of the two hydrocarbons. The two hydrocarbons that we have are alkanes and alkenes. So this takes us back to our definition, where we are defining alkanes as a group of saturated hydrocarbons. So there are two key terms there. Number one, saturated. So being saturated, it means that they only have single carbon to carbon bonds. There are no double bonds. That is what saturated means. And hydrocarbon, it means that it is a compound which has carbon and hydrogen atoms only. Alkanes have covalent bonds as they consist of non-metal atoms. So the alkanes, they only have covalent bonds just because they are non-metal atoms. From bonding, we know that a metal and a non-metal, a metal and a non-metal, this results in an ionic bond. This results in an ionic bond. And when there are two non-metals, a non-metal and a non-metal, and a non-metal, this is where we have a covalent bond. So this is the case now with alkanes. We only have non-metal atoms, which are carbon and hydrogen. So the bonding which exists between those atoms are covalent bonds. Then we have the general formula for alkanes, which is CnH2n plus 2. So this is the formula that we use to predict the formula of any hydrocarbon or of any alkane that we have. So we want to use our general formula for alkanes to deduce the molecular formula of the first two members of the alkanes. So the first member of alkanes, this is methane. So methane, from the name meth plus ane, so this means it has one carbon. This prefix indicates that methane has one carbon atom. So N in our general formula indicates the number of carbon atoms. So we are going to say on N we are going to substitute with 1. So it becomes C1 H2 multiplied by 1 plus 2. And if we simplify this C1, we just leave out the 1 because it doesn't change the number of carbon atoms. 2 by 1, this is 2 plus 2, we get 4. So it becomes CH4. Then for the second member of alkanes, we have ethane. So ethane, it has 2 carbon atoms. So if we substitute the number of carbon atoms on N, this becomes C2H2, and we substitute 2 here plus 2. So this now becomes C2, this just becomes 2, and just erase it here a little bit. So this just becomes C2, so 2 multiplied by 2, this is 4, plus 2 becomes C2H6. So you can see now that the general formula is just used to depict or to deduce the molecular formula of any member of the homologous series of alkanes, given that you know the number of carbon atoms. Thank you.